In the next part of our lesson, we're going to be looking at the relationship between road rage, behavior where someone drives aggressively, and the likelihood that they got a ticket. Now, you would think that these two things are dependent because the more road rage someone exhibits, the more likely they are to be pulled over and get a ticket. But what we're going to do is prove that. So first thing that we're going to do is we're going to define two variables. Let's suppose that R equals the event that someone is a road rager, and T is the event that someone gets a ticket. And then we're going to pick one of the variables. It really doesn't matter which one you pick, but I'm going to pick ticket. And we're going to find the probability of ticket. Now, if you look up here at the table, ticket is in this column. So if we take this number and this number and add them together, that gives us the likelihood that a randomly selected driver has gotten a ticket. And 8 plus 10% gives us 18%. The next thing that you're going to do is you're going to find that same probability again, the probability of the ticket, but given that road rage happened. So now what you have to think is, if road rage happened, we are only looking at this row of the table, which means that rather than being out of 1, we now have a denominator where it's out of 8% plus 12% is 20%. Of those 20%, only these got tickets, so 0.08. And if we divide those two numbers, we're going to end up with 40%. So, in sum, a random individual has an 18% chance of having gotten a ticket, but if you're a road rager, that increases to 40%. So the answer to the question, are they independent or dependent, is T and R are dependent, and the reason is that the probability of T is not the same as the probability of T given R. Second question asks you, are T and R mutually exclusive, or in other words, disjoint from each other? Do they have an overlap? And the answer is yes, they have an overlap. So R and T are not disjoint because the probability of R and T is, here, let's go back up. Let's see, here's R, here's T. The overlap is 8%. And if they were disjoint, then it would be 0, but it's not 0. All right, head to the next video.